Hi, today we've got a three-part integration question, and this is from step 1. So let's see what this entails. So we got I equal to cos integral of cos x sine x over sine x plus cos x from a to 0 in respect to x, and we've got j as we're integrating sine x over sine x plus cos x from a to 0 with respect to x for when a is greater than 0 or equal to or less than 3 over 4 pi. By considering I plus j and I minus j, show that 2i equals a plus ln sine a plus cos a. Now notice how we've got I plus j and I minus j. Well, if we sum these two, we get 2i. So essentially we need to find the result of I plus j and I minus j. So let's start off with I plus j. Okay. So if we add these two integrals, we get sine x plus cos x all over, well, the denominators are just the same, so we get sine x plus cos x on the bottom. And again, we're integrating from a to 0. The reason we can add because the bounds are the same, differentiating with respect to x. Now this just simplifies down very nicely to 1. Now if you integrate 1 with respect to x, we have x from a to 0. If we evaluate the expression, we just get a. Now I minus j. So we have integrating from a to 0, we've got I as cos x on the top minus sine x all over sine x plus cos x. Notice how the derivative of the numerator, so the denominator, is on the top. So we can evaluate this to be ln sine x plus cos x from a to 0. Now if we evaluate this, we've got ln sine a plus cos a minus ln sine 0 plus cos 0. So we can't evaluate this expression any further, so ln sine a plus cos a remains the same. Now on to the second expression, we're minusing ln sine 0 plus cos 0. You know, sine 0 is 0, cos 0 is 1, so we're subtracting minus ln 1, and we know ln 1 is just 0. So we have ln sine a plus cos a as our value for I minus j. Now that we've got these two values, we can simply go ahead and sum these two. So we have a, so we have 2i equals a plus ln sine a plus cos a. Now if you scroll up, this matches what we need to show, so we can say this has been shown. Now on to part 2. Find the integral from pi over 2 to 0 cos x all over p sine x plus q cos x, where p and q are positive numbers. Now I've already written in I and j, because obviously we're trying to use a similar idea from the last part. So we have I cos x. So we need to, we're trying to find I, right? And the way we'd go about this is using a similar logic from the last part. So to get a cancellation of the fraction down to 1, we need to have q cos x and p sin x on the top. So the way we do this, we bring in qi to give us q cos x on the top, plus p j, which gives us p sin x. Now if we sum these, we get 5, 2, 0. We have q cos x minus p sin x. Sorry, plus p sin x all over p sin x plus q cos x. Now this is nice because again we cancel down to 1. Sorry. Yep, that was right. And this, if we skip a step and evaluate this, this is simply just pi over 2. 1 integrates to give us x. X from 0 to pi over 2 has an area of pi over 2. Now, for the negative part, well, we need to have it so that we've got, well, if you see in the last part, with the subtraction of j from I, we had that our numerator was the derivative of our denominator. So again, if we check what the integral of this is, we have, sorry, the derivative, we have p cos x minus q sin x. So what we're doing here is we need to bring in p cos x, which is pa, and we need to subtract qj, so that's q sin x. So let's go ahead and check this works. Pi over 2 to 0, we've got p cos x minus q sin x all over p sin x plus q cos x with respect to x. This integrates to give us ln p sin x plus q cos x. Let's quickly check. P sin x differentiates to give us p cos x, q cos x differentiates to give us minus q sin x, and we're evaluating the area from pi over 2 to 0. So now if we evaluate this, we have ln p sin pi over 2 plus q cos pi over 2, and we're subtracting ln, so we have x is 0, now let's quickly evaluate this. We have ln p sin pi of 2. Sin pi of 2 is 1, so we've just got p plus q cos pi of 2. Cos pi of 2 is 0, so we just have ln p for the first expression. We're subtracting ln p sin 0, which is just 0, and q cos 0, which is just q. And using laws of logs, we have ln minus pi over q as our simplified expression. Now, we need to use these two expressions here to form I. Now, if we simply add or subtract, we've still got both our j terms. Why is this? Because p plus minus q, p minus q, does not make our j term disappear, neither does subtracting them. So what we do here is we force the j term to have the same coefficient. So for our first expression, we multiply by q. So we have q squared I plus pqj is equal to pi over 2. And then similarly for the second expression, we do p times, what was it, pi minus qj, p squared I minus pqj equals ln minus pi over q. Now, with our newly formed equations, we can simply just sum these two. So if we sum them, we have p squared I plus q squared I, pqj minus pqj is 0, so they just cancel. Then on the right hand side, simply just adding the terms. And like I said at the beginning of this part, we're trying to find I. So I equals pi over 2 plus ln minus pi over q all over p squared plus q squared. And that is this integral here evaluated. On to the final part now. Find the integral from pi over 2 to 0 of cos x plus 4 all over 3 sin x plus 4 cos x plus 25 with respect to x. Now again, I've already brought in I and j, where I is simply just the question and j, or in this case, is sin x plus 3. I'll show you why I've chosen to use sin x plus 3 as the numerator. So let's start off by adding. Now, if we add I and j, we'll have cos x plus sin x plus 7 as the denominator. Now, this doesn't really help when we're integrating, as it doesn't cancel to give us 1, nor is it the derivative of the denominator. So instead, we might have to multiply I and j by some constant. Now, if we're trying to cancel, we need to have 4 as a coefficient of cos and 3 as a coefficient of sine plus a 25. Now if we have 4i, we'll have 4 cos x plus 16 on the top. And if you have 3j, we'll have 3 sin x plus 9. And that 9 from 3j and the 16 from 4i sum to give us 25. So this is looking good for us. Now, let's go ahead and combine. So put pi over 2, 0, 4 cos x plus 3 sin x. And our constants, so 4 times 4 is 16, 3 times 3 is 9, 16 plus 9, 25. Perfect. We've got our cancellation. So we are differentiating with respect to x. This nicely simples down to give us 1. Then evaluate that, we have pi over 2. Right, now what we're trying to do. So we've done the case where we have some scale of I times some scale of j to give us to cancel and give us 1. Now we need to look here and go about it where the derivative of the denominator is on the top. So what is our denominator? 3 sin x plus 4 cos x plus 25. Let's differentiate. 3 sin x differentiates to give 3 cos x. Minus 4 sin x is the derivative of 4 cos x, and 25 of course is a constant. So differentiates to give us 0. So we need to form 3 cos x minus 4 sin x somehow on the top. The way we do that is by, now let's look, we need our constants to cancel somehow. So the lowest common multiple of 4 and 3 is 12. And that works perfectly because 4 times 3 is 12, 3 times 4 is 12. So we need times I by 3. So 3I. And we're trying to get minus 4 sine x. So what we'll do, we'll minus 4j. Let's quickly write this out. So we've got pi over 2. And we've got our lower bound as 0. We've got 3 cos x minus 4 sin x. And then on the denominator, saying 3 sin x plus 4 cos x plus 25. The reason our 12's cancelled is we've got a 12 from 3i minus 12 from 4j, 12 minus 12, 0. Perfect. Now if you integrate this with respect to x, we get ln 3 sin x plus 4 cos x, and don't forget our 25. And the area is from 0 to pi over 2. So let's evaluate this real quick. Ln 3 times sine pi over 2. So that's 1. Sine pi over 2 is 1. So that gives 3. 4 cos pi over 2, 0. Plus 25. So that gives us ln 28. Subtract. Ln 3 sine 0 is 0. 4 cos 0 is 4. Plus 25, which gives us ln 29. Laws of logs. Ln 29. Right. So what have we got? Let's write this out more clearly. We've got 4i plus 3j equals pi over 2. We've also got, let's look, 3i minus 4j equals ln 28 over 29. Now, again, I should have stated, but we're trying to find I. Put a big question mark next to that. And so basically, put two simultaneous equations, we want I. So we need to force j's to cancel. Again, the lowest common multiple of 3 and 4 is 12. So let's times equation 1 by 4, equation 2 by 3. So we've got 16i plus 12j equals 2 pi. And then we've got 9i minus 12j equals 3 ln 28 over 29. Now let's go ahead and add on two new equations. So on the left hand side we've got 25i equals 12j minus 12j 0, 2 pi plus 3 ln 28 over 29. To get I, divide through by 25. This will give us 2 over 25 pi plus 3 over 25 ln 28 all over 29. And that's it. That's a 3-part integral from step 1 completed. Hope you enjoyed and took away the trick from this question. Hope to see you in the next